All right, so let's say we want to find a bunch of solutions to this equation here. Y is equal to 5 over 9 x minus 7. Let me go ahead and zoom in so we can see that clearly. We could choose a bunch of different values for x and plug those in one at a time. Or we could find one value, one pair of x and y, and then use our ratio of change to find the other values. So I'm going to first find one value, so I can choose anything I want to plug in for x and find a y value that would make a solution pair here. If you know me, you know that I love the number 0. So I'm going to let x equal 0. 5 over 9 times 0 minus 7 would give me y is equal to 0 minus 7. So y is equal to negative 7. So that would give me the xy solution 0, negative 7. All right. Now, when we put this into a table, we should be able to see really quickly that it's very easy to get to other solutions. So I'm actually going to put this kind of in the middle of my table because I want to find sort of a variety of solutions here. And what I know is that my change in y, change in y is 5. My change in x is 9. Change in x. So every time my y changes by 5, negative 7 plus 5 would be negative 2. My y changes by 9. 0 plus 9 would be positive 9. So now I've got two solutions. If you don't believe me, plug in 9. 9 divided by 9 is 1. 1 times 5 is 5. 5 minus 7 is negative 2. And I can keep going. Add 5, I get 3. Add 9, I get 18. Right? Again, you can plug that in and check to see that it is in fact a solution. I could also go in the other direction because it turns out that subtracting 5 over subtracting 9, right? Negative 5 over negative 9 is the same thing as 5 over 9, that same ratio of change. So negative 7 minus 9 would be negative 18. I'm sorry, not 9 minus 9. No, that would be wrong. It would be negative 7 minus 5. So I want to have negative 12 here, right? And 0 minus 9 would be negative 9. I can subtract 9 again and I would get negative 18. And on the output, if I subtract 5, I would have negative 17. And again, if you don't believe me, plug negative 18 in here. Y would be equal to 5 over 9 times negative 18 minus 7. That would be negative 2 there. So it would be 5 times negative 2 is negative 10 minus 7, which is in fact negative 17. So what we can see here is a really quick way to generate a bunch of solutions. Find one easy solution. I found 0, negative 7 by choosing a value for x and finding the y value. And then use that ratio of change, the ratio between how your output changes and how your input changes, or how your y changes and how your x changes, to find other values. Right? I'm going to give you one little hint down here, and then I'm going to let you do the rest. What is my ratio of change here? Well, in the place of that ratio, I see a 3. Unfortunately, that makes it hard to see the change in y and the change in x. So we have to think about fractionizing 3. How do we write 3 as a fraction? How do we write that as a ratio? Well, it would be 3 to 1, right? 3 over 1 is the same thing as 3. So now you can see your change in y compared to your change in x. Do me a favor, create a table, x, y, at least 5 pairs of solutions, and bring that to class tomorrow.